So write the problem over here in the margin, guys.
Stop it.
It's 3x squared minus 3x minus 5. And we're going to add to that 2x squared plus 5x plus 3. This problem is right here. I'm just copying that, and I'm going to do the work up here to show you guys like the way I would do it. Okay? Now to teach you guys how to do it, they're trying to show you guys algebra tiles, which is, I think, good for a visual. So let's just look at it for a visual. I'm not going to actually do algebra tiles with you guys because I think that some of you guys will just be like, oh, come on, I don't need this. So right here, it says 3x squared. It says 3x squared. So how many x squareds are there?
2.
Shh. So because it says 3x right here, 3x squared, we're going to have 3x squared squares right here. Okay? Over here we have 2. So we should have 2 right here. So class, how many total x squareds do we have?
5.
Yeah, there's 5 of them. 5x squareds. Okay? Notice that you can only add the x squareds to other x squareds. Now look at the next one. This says negative 3x. So we have 3 negative x's right here. Those are the rectangles.
Yeah.
This says negative 5, or sorry, positive 5x. So we have positive, or 5 of these. Now what's neat about the negatives and the positives is when you put those next to each other, or when you combine them, they cancel each other out. So if I was actually doing algebra tiles, I would put the other x's right next to it, because these are all negatives. They would cancel these ones out. So what are we left with?
Those.
We're left with positive 2. So positive 2x, which actually can just be done by using your understanding of adding positive and negative numbers. So negative 3 and positive 5. If I add those together, what do you get? Negative 3 and positive 5. Oh, you get positive 2. Okay, which we just saw with our algebra tiles right here too. Next we have our constants. We have a negative 5 right here and a positive 3. So we have
-2.
5 negatives and 3 positives. And if I were to use my algebra tiles, I would be going like this. I would cross out 1 and 1, 1 and 1, and 1 and 1. And so what are we left with?
2.
Those.
No.
Negative.
Negative 2. So this is your answer. Now you cannot add this x squared term with this x term. You cannot add those together because they are not like terms. Okay? I think that's really easily seen when we look at the tiles. The tiles are different. You cannot combine the big squares with the tall rectangles. You just can't do it. So what I want you guys to do right now is try these ones. Try these right now on your paper. I'll walk around and help you guys, and then I'll throw the answers up so you guys can check.
Breathe.
Okay, so for this first one, now mine says x squared, but I believe all of yours says just x. Like that, right? It's just x minus 2 and 2x plus 5. So when you do this, we look at the x terms. We have 1 right here and 2 right here. So how many total x's do we have, guys? There's 3 x's. We have negative 2 constants and 5 constants. So what is that?
Plus 3.
That's plus 3. All right, that's your answer for the first one. So the second one, we have, how many y squares do we have right there?
5.
No, we have 2 right there. How many y squares do we have right there? 3. And so combine it.
5.
That's what you guys are saying. 5y squared. Okay. So I have 3 y's right there, but there's no y's over here. So we're just gonna write 3 y's. So that one's done. That one's done. That one's done. Now I have some constants right here.
That's 2.
Yeah, that's 2. Very good. Okay, next one.
X squared.
Mr. Patey, so we don't add up the y?
Guys, students.
Shush, I got a question.
Hey, we don't add up the exponents, no, because we're not multiplying.
Okay.
We only add exponents when we multiply. And since we're adding the terms, you don't do anything with the exponents. The exponents just tell you which ones are like, which ones are not. Like, I'm not going to add this 2 to this 4. Because that 4 has an x, and that one has an x squared. So, I need to find the other ones that have x squareds. So if I add those together, that's a 2 and that's a negative 1. If I add those together, what do I get?
X squared.
I get 1x squared. Now, I don't need to have that 1 right there, because 1s can be a ninja. So I'm done with my x squareds. I have a 3x right there, and a negative 4x right there. So how many x's, class?
Minus X.
Yeah, minus 1x, which is just minus x. And the last one are the constants. So I have a constant right here and a constant right here. That would be plus 3. You're right.
We don't care.
Okay, the last one, now the last one's different. Why is the last one different? Can someone tell me?
Because backwards.
The order's all messed up. Yeah, they're not in standard form. Right here, this one's completely backwards, and this one's just messed up. Look, the constant's not even first here. He's supposed to be over there. Okay, so I get 1x squared there and negative 3x squared there. So how many total x squareds do I have?
Negative 2x squared.
Yeah, negative 2x squareds. Okay, now somebody else shout it out. Somebody tell me if you know how to do this. How many x's do we have?
1.
There's negative 1. Good, negative 1x.
Plus 9.
Okay, and then our constants?
Plus 9.
Yes, that's correct.
Did he
Plus
say
9. He said 9. That's 9.
the heck is
There's another way to do this, and they talk about it later in this section, but I'm just going to do it right here so we can move on to the next part. And what they do is they take these two polynomials and they add them up vertically. How does that look? Well, I'm going to go ahead and rewrite this. I'm going to put the x squared first, so I'm going to have x squared right here. I'm going to put a 1 in front of it just so I know that there's a 1. And then I'm going to put the negative 3x, so I'm going to put negative 3x right here. And then the last one is a positive 5. So that's the first one. The next one, I'm going to write underneath it so I can add them together. But I want to put the x squared term underneath it. So what's my x squared term right here? Negative 3x, right? Negative 3x squared? Negative 3x squared. What's my x term that I put underneath the 3x? Is it going to be 4 or 2x? 2x. And the last ones are constant, so I'm going to put the 4 underneath that. Now this is kind of neat because look, they're all lined up. What's 1 and negative 3? Negative 2. X squared. Next one is negative 1. X. And the last one is 9. So I get the same answer. It's just a different way to think about it. Some people really like this because it helps them add like terms. So over here at this problem, they're just asking us to find the ones that are like terms. So if you have a highlighter, you can go ahead and highlight that.
No, Larry.
Okay? If you don't have a highlighter, you can borrow one of mine later. Actually, that's too dark. I need it a little lighter. So here it says, like terms and expressions are terms that have the same variable and exponent. So let's have the same variable and the same exponent. So 2x and 2x to the third. Are these like terms?
No.
Nope.
I knew it, but I knew.
Are these ones like terms? The 5 and 5x?
No.
Nope.
Yes.
They have to have the same variables and they have to have the same exponents. What about this last one?
No.
It says negative 3y and 3y. Do they have the same variables?
Yeah.
Do they have the same exponents?
Yeah.
Yes. So we're going to say yes right here. And if I go down more, it says, okay, that one we already did. That one's a yes. Okay, what about this one though?
No.
Do they have the same variables?
Yeah.
Yeah, but do they have the same exponents?
No.
No, so that means this is not, those are not like terms. What about this last one?
No.
I love this one because it looks kind of confusing. Does this one have any variables?
No.
Does this one have any variables?
No.
So they're both constants. That means they are like terms.
Wait, so even if there's a negative, it doesn't matter?
Right. The negative in front of the regular number doesn't matter.
Wait, why are